Hello and welcome to another Common Core Algebra 2 lesson by eMathInstruction. My name is Kirk Weiler, and today we're going to be doing Unit 1, Lesson 5 on multiplying polynomials. In the last lesson, we looked at multiplying polynomials by monomials and monomials by monomials. A lot of this starts to sound like Greek pretty quickly. But today, we're going to be looking at how we can multiply polynomials by each other, how to keep track of that multiplication, and how to kind of think about it also geometrically. So let's jump right in. Okay, exercise number 1. Given the polynomial 2x cubed plus 5x squared plus 3x plus 4, what is its value when x is 10? How can you determine this without the use of your calculator? If you cannot, use your calculator to help, and then explain why the answer turns out as it does. So polynomials are kind of interesting, and in Algebra 1 you should have looked at this a little bit. But the polynomial 2x cubed plus 5x squared plus 3x plus 4, well, when you put x equals 10 in, right, then hopefully what you know, that was supposed to look like a 5, is that what we really have here, 10 cubed by definition, is 1,000. 10 squared by definition is 500, or 100, then multiplied by 5, and then obviously 30 and 4. So this is 2,534 when x is 10. You see, polynomials are just an extension of what's called our base 10 number system, right? When we have a base 10 number, like 7,358, this is just 7 times 10 to the third, plus 3 times 10 to the second, plus 5 times 10 to the first, plus 8. The big difference is that when we have a polynomial, the base doesn't have to be 10. It could be anything. On the other hand, if we have a polynomial and we decide to put in a base of 10, then it makes it very, very easy to think about what its value is. All right, so let's now talk about multiplying polynomials. I'm going to clear out the text, so please press pause if you need to. Okay, here it goes. Let's get into some polynomial multiplication. Now, when we look at a product like 3x plus 2 times 2x plus 5, it's very similar to multiplying 32 by 25, okay? We have to make sure that everything inside of this parentheses, 3x plus 2, all terms inside of this parentheses, multiply all terms within this parentheses. And it says, find this product using the distributive property twice or possibly foiling. We'll come back to that in a moment. But what we mean by using the distributive property twice is that the first thing that I'm going to do is I'm going to distribute the 3x times 2x plus 5. And I'm also going to distribute the 2 to the 2x plus 5. All right, now each one of these individually isn't too bad, right? This thing becomes 6x squared plus 15x, and this one becomes 4x plus 10. And then, no great surprise, we can combine like terms here, but nothing else, into 19x. So there we go, 6x squared plus 19x plus 10. Many math teachers call this process foiling. Okay, that stands for first, outer, inner, and last. Normally I wouldn't introduce something like this unless it was something that was used by lots and lots of teachers, which it is. But really, foiling is only helpful when you're multiplying a binomial by a binomial. But the idea is, oh, I'll multiply the first two terms. 6x squared, I'll multiply the outer terms. 15x, I'll multiply the inner terms. 4x, and then I'll multiply the last terms, plus 10. And then when we combine like terms, we're back to where we started. Now, a lot of people like to talk about multiplying binomials using what's known as an area model. Now the reason for that is that area of a rectangle is simply length times width. So if we have 3x plus 2, we can kind of think about that as having a length of 3x and a length of 2 and adding them together. 2x plus 5, that's like having a length of 2x adding to a length of 5. And when we multiply them, we get this larger rectangle. The area model then would say, well, I've got 3x times 2x. This rectangle would have to have an area of 6x squared. 3x times 5, this rectangle would have to have an area of 15x. 2x times 2, this rectangle would have an area of 4 times x. And then 2 times 5, that would just have an area of 10. To get the total area, we'd add them all up. Nothing combines with the 6x squared, but then 4x and 15x combine to be 19x. And again, nothing combines with the 10. So we can often look at multiplying polynomials, especially when everything's positive and being added. We can then look at those in light of an area. If we had 2x minus 5, that makes it much more difficult to think about this as area, right? Because we wouldn't have a length of negative 5. You could still do it, though. You could use the area model. It just would lose a little bit of the connection to real rectangular area. Okay, I'm going to clear out the screen, so write down what you need to. Okay, let's clear it out. Find the product of the binomial 4x plus 3 with the trinomial 2x squared minus 5x minus 3. Represent your product using an area array. Even though the result has an x cubed term in it, an area array can still help us keep track of the product to make sure we're distributing correctly. So we don't need to draw any pictures to do this. Okay, but it certainly doesn't hurt. In other words, what I've got now, I've got a slightly different kind of area problem here. Got an overall rectangle. On one side, we're just going to have two terms, a 4x, and I think I'm going to attach the plus 3 down here. On this side, on the other hand, we have three terms. We have a 2x squared. I'm going to attach that negative to the 5x and that negative to the 3. But now what we have is we have 6 rectangles. Now they don't all have the same area the way that I've drawn them, but we don't really need them to be scaled correctly. We just want to be able to go 4x times 2x squared is 8x cubed. 4x times negative 5x would be negative 20x squared. 4x times negative 3 would be negative 12x. We can now do this row. 3 times 2x squared would be 6x squared. 3 times negative 5 would be negative 15x. And 3 times negative 3 would be negative 6.
Oh my God!
Now it's really
No
just
way!
combining like terms. Well, 8x cubed is 8x cubed. Nothing that we can combine with that. And notice now how these two terms and these two terms are like terms, right? So 6x squared minus 20x squared would be negative 14x squared. Negative 15x, negative 12x, be careful, would be negative 27x. And then nothing combines with the negative 6. So there's our product. Now there's absolutely no reason why you have to draw that picture. You know, you could just distribute the 4x, take this, distribute it through, then take the plus 3 and distribute it through. And I'll do that sometimes as well. But the area array helps us keep track of all the various products going on. All right, I'm going to clear out the text, so pause the video now if you need to. Okay, here we go. Let's keep doing some products. Exercise 4. Consider the product of x minus 2 times 2x minus 5. Evaluate this product for x equals 4. Show the work that leads to your result. All right, so well, first let's just put down the product. X minus 2 times 2x minus 5. And it says evaluate the product for x equals 4. In other words, I'm going to put 4 in. 4 minus 2 times 2 times 4 minus 5. We just need to be careful here. 4 minus 2 is 2. 2 times 4 is 8 minus 5. And then I'll get 2 times 3, and it looks like the product's equal to 6. Because remember, that product will always depend on what x is. Now letter B, find a trinomial that represents the product of these two binomials. We can do this using area, we can do it using foiling, we can do it using double distribution. I think I'll just do some foiling. First, outer, inner, and last. Notice how we always have these kind of combining like terms. All right, 2x squared minus 9x plus 10. Letter C says evaluate the trinomial for x equals 4. Is it equivalent to the answer you found in A? Well, I don't know. Let's take a look. Let's see if it's equivalent. So I'm going to take this trinomial, 2x squared minus 9x plus 10, and I'm going to put a 4 in for it. Let's see what we get. Again, let's try to do as much of this without a calculator as we can, just to get practice on our mental arithmetic. Order of operations says I've got to square that 4 first. All right, then 2 times 16 is 32. 9 times 4 is 36. All right, a little bit tricky here. Be careful now. 32 minus 36 is negative 4. And negative 4 plus 10 is 6. Yep. And of course, the reason that happened, in fact, this is the whole purpose of this problem, is that when we multiply two binomials together, or something even more complicated, and we get that trinomial is equivalent to this product. These two things, let me circle them both, these are equivalent, all right? In other words, they are the same thing forever and always for all values of x. Now, let's take a look at letter D. It says, what is the value of the trinomial when x is equal to 2? All right, so what I'd like you to do is pause the video right now and evaluate what that trinomial's value is. So take this guy, bring it down here, and then plug x equals 2 in, and see what its value is. Pause the video for a moment. All right, let's take a look. Well, I don't know, I mean 2, 4. I just gotta try it, right? See what the situation is. Again, kind of working through this little by little. 8 minus 18 plus 10. Again, let's be careful. 8 minus 18 is negative 10 plus 10. It's 0. All right. Now, why is that thing 0? Well, take a look at the original expression, x minus 2 times 2x minus 5. Well, if I put x equals 2 in here, right, and I'm going to just put a dash through there, because it really doesn't matter, right? I don't care what 2x minus 5 is. If I have a 0 here, then a 0 times anything is 0. This is known as the zero product law. And it's very clear that when I look at the product in x minus 2 times 2x minus 5, it's very clear to me that putting in x equals 2 will force this product to be 0. In its trinomial form, it's not obvious at all. And we're going to look at that a lot this year when we look at the connection between what are known as factors and what are known as zeros. This is our sort of first look at it this year. Okay, well, pause the video now, write down anything you need to, then we'll do a little bit more. Okay, let's clear it out. Exercise 5. The product of three binomials, just like the product of two, can be found with repeated application of the distributive property. Find the product, use area arrays to help keep track of the product. So look, anytime you have the product of more than two things, it's always tricky, right? Forget about this just for a minute. If I simply had this, 5 times 2 times 7, well, you got to make a decision. Since multiplication is commutative and associative, you can choose any two to start with and then bring the third in later. So for instance, I could do 5 times 2 and get 10 times 7 and get 70. Or I could do 2 times 7 and get 14 and then multiply by 5 and get 70. I could even do 5 times 7 and get 35 and then multiply by 2 and get 70. So it's the same way here. I really have to multiply 2 of these, your pick, and then I have to go back and multiply by the third one. So it's really up to you. For whatever reason, I almost always start here. So in other words, I'm going to multiply these. And let me do a little bit of foiling. I'm going to do first x times x, then outer negative 7 times x, then inner 4 times x, and then last 28. Then I'm going to have x minus 2. Let's combine some like terms. X squared minus 3x minus 28. All right. Now, how do I proceed? Well, now I have to multiply by x minus 2. And I think in this case, what I'm going to do is I'm going to do double distribution. I'm going to first multiply through by x. Gives me x cubed minus 3x squared minus 28x. I'm going to multiply through here, and watch as I do something a little bit weird. I'm going to kind of stack it almost like I'm doing double digit multiplication. Negative 2 times x squared, negative 2 times negative 3x. Remember, it'll turn that positive. Negative 2 times negative 28, again, be careful. We'll also turn it positive. Now I'm going to combine these like terms. Nothing combines with the x cubed. Here I'll have negative 5x squared. Here I'll have negative 22x. And again, nothing combines with the 56. Ooh, cubic. Letter B asks, for what 3 values of x will the cubic polynomial, this thing, that you found in part A have a value of 0? What famous law is this known as? Well, keep in mind that this is exactly the same, just written in a different form, as this. The question is, well, what would make this expression equal to 0? Well, if I put x equals 2 in, it would, because it would make this thing equal to 0. If I put x equals 7 in, it would, because it would make this equal to 0. Maybe the trickiest one is if I put x equals negative 4 in, it would make that equal to 0. This thing is known as the zero product law. If any one of those 3 things is equal to 0, then the whole thing would be equal to 0. And the really remarkable thing is that, yeah, if I take any one of those 3 numbers and I substitute it into this ugly polynomial here, it should give me 0. So let's do the easiest one. Let's test it with x equals 2. All right, so I'm going to put 2 in. I'm going to do 2 cubed minus 5 times 2 squared minus 22 times 2. Ooh, plus 56, let's just hope. 2 cubed is 8. 2 squared is 4, obviously. I think I'll leave the rest of this unevaluated for right now. Now I'll do the multiplication. We'll get 8 minus, oh, I'm getting near the bottom of the screen. All right, now I got to just work my way this way. I'm going to get 8 minus 20, which is negative 12 minus 44. Whoops. That would help. Plus 56. Continuing to work this way, negative 12 minus 44 is negative 56. Plus 56 and 0. Remember, all a 0 is the value of x that makes an expression equal to 0. So therefore, the fact that we got 0 at the end is a good thing. Okay, we'll pause the video now, write down anything you need to. All right, clearing out the text. So one of the fundamental skills that you need in Common Core Algebra 2 is the ability to multiply a polynomial by another polynomial pretty quickly, pretty accurately, right? And of course, we're going to get a lot more work on this skill as we go forward. But I wanted to make sure that you saw it for the first time, at least in review, in Unit number 1. All right. Thank you for joining me for another Common Core Algebra 2 lesson by eMathInstruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.